Hi, and welcome back to AI for Teachers. In today's episode, we're diving into what I think is one of the most powerful ways to make abstract STEM concepts truly click for students, and that's interactive simulation programs. Simulators let us turn ideas that normally only live in textbooks or diagrams, like the fetch, decode, execute cycle inside a CPU, into dynamic, visual, hands-on experiences. So instead of just reading about how a processor works, students can watch instructions flow for each stage, tweak variables, and see how the system responses or how the system responds in real time. And the same approach can bring to life everything from forces and motion to chemical reactions to population models in biology. And with today's AI tools, creating these kinds of classroom ready simulations is easier and faster than ever. You don't need to be a software engineer. You just need a clear learning objective and a willingness to experiment. So AI can help generate code, build the interfaces, model behaviors, and even tailor the simulation to different year groups or exam groups. And by the end of this video, you'll understand why simulators are such a powerful teaching aid, how they boost engagement and understanding, and how you can start building your own custom simulations to match your curriculum. So let's get started. During the course introduction, I've shown you several simulators I've created to demonstrate these ideas already. Each one of these took only a few minutes from the initial prompt to working tool. So let's dive in. While there are many AI tools for coding and also models specifically created for that task, in today's video I'm going to be using Antigravity. Now this is the latest tool from Google. You can see the main screen at the moment being shown. This is currently in preview and it is free at the moment. Unfortunately, I doubt it's going to stay that way when it goes full non-preview version, but for the time being I certainly suggest you have a look at it, see what you can actually do. So as mentioned, this is the main screen. Before then, let's just have a look at the website there. So if you do a search for anti-gravity on Google, or you can go directly to antigravity.google, you'll see this screen here. The main thing to look at is this download button, and this allows you to download the application for any of them, well, for all the major operating systems, certainly desktop operating systems. Now let's have a look. Go back to anti-gravity. As mentioned, this is the main screen. We're going to open a new folder. So let's just go here. I'm just going to create a new folder called Maths Test. Obviously I'd probably create one more meaningful if I was keeping this, so let's just open that. We can trust the authors because the authors are ourselves, or in this case certainly Google. This is the main interface, divided into three main panes. The pane we're going to look at first of all is on the right hand side, called Agent. Now this should be fairly familiar to all those that have used any of the major chat models, and this is our actual chat interface there. So I'm just going to paste my prompt in there, and my prompt is I'm teaching my year 11 GCSE and A-level students or math students about graphs. Create me a single file HTML simulation I can use to demonstrate the following. So transformations of graphs, etc. I'm not going to go into detail there except for one part here which is very important. I've asked it to create a single file HTML simulation. Now the reason that is, I don't want to be messing around with trying to install libraries or run up any additional environments to actually run the simulation. I want to be able to open a single HTML file page in a browser of my choice such as Chrome and have everything I want working. That's also very easy to distribute if you want to send it out to your students, but also you don't be messing around trying to set this up in front of a class, especially if you're going through several different simulators during the course of a lesson. Open up a single web page and you're there. So I've got this selected. I'm just going to click the button now to send it. Now the intention here is to do this in real time. Unfortunately that may result in hopefully not too long periods, but certainly short periods of where I'm unable to actually add any audio because I don't feel it necessary. But at the time being, it's now going through and analysing our request, and you can see on the output it's giving us feedback, and it's currently thinking. It's now, if we look at the center pane there, this is one of the outputs it's produced. So this is an implementation plan. So it's going through, looking through the implementation plan. You can go through and read that. But on the right hand side now, you can see it's actually generating. It's working through the implementation plan, which it has created from our initial prompt. And it's just said, I finished the preliminary tasks, and I'm now starting on the core implementation. So here, it's actually creating the HTML page. And again, it won't just be HTML, because obviously it is interactive. So we'd like to see CSS and a large amount of JavaScript. So it's currently going through and it's telling us that there anyway. If you look on the right hand side, CSS styling, and then I'm going to start to flesh out the JavaScript for the interactive elements. So it's giving you feedback on exactly what it's doing, the whole process. And once more, it's having a good think about how to actually implement that. And once it's done that, it will start to create that. Once it's actually created that, it does also go into self-testing mode. Now that sometimes can take a little bit of time. But one of the things we can do is also open up the file that it produces while it's testing it and test it ourselves. So here we go. So it's now opening. There we go. So it's actually created that. I'm not sure how long that was, but it certainly feels like under 2 minutes. This is what it's actually created for us. So it's quadratic. So this is actually being run now by the model itself, by Antigravity. It's actually testing it for us. And that's all very well, but let's just copy that. I'm just going to create, and you can sit there and actually have a look at it, but it's much faster. I'm actually going to create a new browser tab, open up the same, and let's see what we've got here. No, I'm not a maths teacher, but certainly let's see what we can do. I mean, certainly from an interactive point of view, it's very, very smooth. I'm assuming this is correct. It will require maybe a maths teacher to actually tell me, but certainly if we're looking at the properties here, as I'm changing this shift, you can see it change here. You can also see that value change up there in the actual equation at the top there. So let's go back to quadratic equation now. Here we go. Got a quadratic equation. Let's look at the vertical shift. Minus, that's fine. Let's look at the vertical stretch. So the first part of that's the vertical stretch. And horizontal. There we go. And then the shift as well. Let's go. I mean, that does look pretty impressive to me, certainly. And again, this is something you can use for demonstration purposes in front of the students, or if it meets your requirements, you can put this onto your Teams or any other collaboration or classroom software you have. They can download this and they can run this within their own browsers and actually see it working. Now, that's been a very quick demonstration. I've showed you some earlier examples I've already created for other topics such as computer science and also maths. I hope you've enjoyed that. Please do have a look at this. Give it a go, and I look forward to seeing you next time. Thank you very much.